Hey guys, we're going to continue through our notes on earthquakes. All right, we have a few more things to go through regarding earthquakes. So first off, I want to talk about seismic waves. All right, I already mentioned as they go deep underground, their speed will change. All right, because you guys know as you go deeper into the earth, the density increases. As a result, the velocity or speed of the earthquake waves is going to change depending on what it passes through. And so if the material is under pressure, meaning it's also going to increase in density, the velocity of the waves will increase. So you increase pressure, you increase velocity. Remember, velocity is another way to say speed, just reminding you. Greater density of material, the greater the velocity of the waves also. Okay, so as the earthquake waves go deeper in the earth, their velocity is generally going to increase as a result. Because remember, those two properties both increase. Okay, now finding the earthquake epicenter. We got to use that P and S wave chart big time. All right, and different things we're going to do with the numbers or data you get. To locate an earthquake's epicenter, you're going to use the difference in arrival times of the P and S waves. So sometimes they're going to give you a seismograph. Sometimes they'll directly tell you the P and S wave arrival times. From there, we know P waves move faster than S waves. So the further away from the epicenter, the larger the difference in time between the P and S waves. We call that the time interval. And there's little techniques we'll use to figure out the distance to the epicenter from those things. So a seismograph 1,000 kilometers away from the epicenter will pick up the P waves 2 minutes after the earthquake. The S waves will arrive 4 minutes after the earthquake. So there's a 2-minute time interval between, and you can actually use your piece of paper to kind of mark that out and figure that out using the reference table. All right, we'll go through examples of that in the notes on that, or I should say just a little practice with that chart. Okay, so we'll play with this a little more in another another YouTube video. All right, but distance to the epicenter is determined by comparing the interval with the graph data. Okay, so we use a strip of paper to mark the time interval on the side, and then slide the marked paper till it fits between the P and S wave curve, and you're going to read the epicenter distance below to figure out how far away the earthquake was. Okay, so that's definitely something you got to practice and do over and over again to get that technique down. Okay, origin time, they're going to give you clock times. If you see a clock time, you don't use that with the reference table page. Instead, you use the P and S wave arrival times first. All right, so the time of the earthquake occurred, origin time can be determined using the epicenter distance and your wave travel times provided. So if the earthquake epicenter is 4,000 kilometers away, it's going to take 7 minutes for the P waves to arrive. Okay, so if we know that, we can take that the earthquake occurred 7 minutes earlier than that first P wave. So we take the P wave clock time and subtract away to find the origin time of the earthquake. All right, we could also do the reverse. Sometimes they want to know when the P wave arrived. If that were the case from the earthquake origin time, you would add instead. So you just got to think sequence of events. That's what I always tell my classes. Okay, so remember origin time of the earthquake, then P waves arrive, then S waves arrive. So if you're going back in time, you're going to subtract. If you go ahead in time, you're going to add. All right, and that's what you got to keep in the back of your mind as you do these. Okay, position of the epicenter. So once again, distance to the epicenter is the important part. You're going to need at least 3 seismograph locations. If you only have 1 or 2, you're going to have too many possibilities of where the earthquake is. All right, the epicenter distances are calculated for each of the 3 seismograph locations, and then the distances are used for radii for 3 circles on a map. And then what we do, we place the 3 circles on the map using a drawing compass, and then we see where the three circles intersect, and then we can figure out where the epicenter is. All right, so here's a quick little example. So if New York had the earthquake and we found out it's approximately 800 miles away, we make a circle that's 800 miles radius. Okay, and it's anywhere along that circle where the earthquake could be. We don't know where the earthquake waves came from. Okay, so the next city that comes in, Chicago, finds out the earthquake is 400 miles away. So now we have two places where the earthquake could be, right here or right here. It's not until we get number 3 in there. Okay, so Atlanta, Georgia figures out 200 miles away, and we see our intersection point. So right there, that's where your earthquake epicenter is. And usually on the test questions, they'll ask you to mark an X where the epicenter located, or they might have points A, B, C, D labeled, which is closest to the epicenter, and you have to pick the one where the 3 circles are intersecting. All right, so that's that example. All right, so we'll practice more of these, and that's earthquakes. All right, thank you guys for tuning in.